Welcome to the lesson on the derivative. So the derivative, probably something you might have heard that term before. People talk about calculus, they talk about derivatives. Um, might sound scary, maybe not, I don't know. The good thing is you basically already know lots about derivatives. So let's say I was to write this. The limit m equals the limit as h goes to 0 of f at a plus h minus f at a all over h. And I said, what is this? From previous lessons, I probably get one of two or two answers. I probably hear slope of tangent at A, slope of at A, maybe A, f at A, or instantaneous rate of change. Rate of change at the same point. Change at that point. Well, I'm going to give you a new meaning, and it also means the derivative of f at x at a f at a. So yeah, that's all derivative means. A derivative is the same thing as the slope of the tangent to a curve at a point. So actually that's sort of the definition of a derivative. A derivative is the slope of a tangent at a point. Okay, so let's do an example. Actually, let me give you some notation. So the notation we use, notation for this is, in order to write the derivative, we will often write f, and we'll put a little dash. We'll call that a prime of x. And we'll see why that notation makes sense in a second. So let's start a new page. So as an example, we're going to find the derivative of f at x squared at the point. Now, I'm not going to give you a nice point. No, I'll give you a nice point. I'll say at the point 1. I think I already did that one. Let's do 2, 2. So what we're going to do is f prime at 2 equals, the limit is h goes to 0, and it's that same thing. F at 2 plus h, so normally it's a plus h, but a in this case is 2, minus f at 2 all over h. So limit is h goes to 0 of 2 plus h squared minus 2 squared all over h. Now again, try direct substitution, won't work. You get 0 over 0. So we'll expand. So we get 4 plus 4h plus h squared minus 4 all over h. 4's go away. 4h plus h squared over h. You could factor in h, or you might just recognize that we can cancel, one on the bottom with one of each of the terms on the top. So the limit is h goes to 0 of, what do we got now? 4 plus h. Let h become 0. You get 4 plus 0 equals 4. So that's the derivative. F prime at 2 is equal to 4. Make sure you can see that. So the derivative to this function at the point 2 is equal to 4. And that just means the slope of the tangent at the point is equal to 4. Okay, same question. Find the derivative of f of x equals x squared at the point, but now instead of giving you a specific point, what happened? Oops. Instead of giving you a specific point, I'm going to do it at a general point. So x squared. Okay. So here we're going to do f prime at, and now I don't have a number, I just have x. So f prime at x equals f at, now normally it would be a, but I'm using x, plus h minus f at x all over h. So x plus h squared would, or x plus h, f at x plus h would be x plus h squared minus x squared all over h. So expand that. We get that. These x's go away. Oh my goodness. You always absolutely have to have the limit here, right? Do not forget that. I forgot that. That's a cardinal sin. You never, do not make that mistake. When you're evaluating limits or doing derivatives, you always have to have this limit here. Because, well, that's a good question. What if you didn't have the limit there? What would you really be doing? Instead of doing the slope of the tangent, you'd be doing the slope of the secant, which is not what you're doing. So again, h's go away. Remember to write my limit. So I get 2x plus h, and now I can let h go to 0. So this is where I don't have to write the limit anymore, because I'm going to let h go to 0. So I'll have 2x plus 0 equals 2x. So I could say f prime at x equals 2x. So this is the slope of the tangent at an arbitrary point. Okay. So what you maybe notice here is, notice this is a function, right? This is a function of x. Of x. And what does this function represent? Well, it represents the slope of the tangent at any point x. Right? X squared look like this. So let's f at x equals x squared. So I can take any x value, right? X equals 4. And if I want the slope of the tangent at 4, I'll just sub 4 into this equation. So f prime at 4 would be 2 times 4, which is 8. So the slope of this line is 8. Let's say I wanted negative 2. So I want the slope of this line. So f prime at negative 2 would be, use this, 2 times minus 2, negative 4. So the slope of this line is negative 4. So this derivative function just gives us a slope at any point on the curve x squared. Okay, so that's really what makes a derivative different than, when we said it's the same as the slope of a tangent, and it is. But usually when we're talking about derivative, we're thinking of it as a function. So a derivative is a function. Hold on. Yeah, let me just. Derivative, we'll say of a function. F is a new function, is another function. And we write this one f prime defined by f prime at x is equal to the limit as h goes to 0, and it's just that definition we had. But now we're doing it at, we want it as a function of x, so we do it at the point where, just the point x. And then usually we'll make one sort of comment provided this limit exists. So we saw in our discussion on limits that sometimes limits don't exist. So in that case, what's going to happen is the derivative won't exist. So we'll see how that can not happen in the next lesson.